Logarithmic properties. Now, we've already been working with a lot of logarithmic properties, and we've talked about things that we can enter in the calculator. In this section, we're going to look at some things that we can't just enter in the calculator, or maybe to help us to assist us in that. First thing we're going to look at is something known as the change of base property. The change of base property is really nice because there's only two logs you can enter into a scientific calculator, log base 10 and the natural log. So if I have any other things I want to be able to enter in the calculator, I'm going to have to pivot and use them off that. The change of base property says that you can rewrite these logs using the common log. And so what you do is you set up a division problem. So you do log, and then remember log base 10 of A divided by log base 10 of B. So instead of working with this base over here that I can't enter in the calculator, I would say, okay, well, I know base 10, so I'll do log of A divided by log of B. And again, I remember which one I'm going to use here. Do you see how, like, positionally this A is higher up than that B? Like, it just looks like it's coming up higher. That's how I remember it goes on top. And this little B down here is a little bit lower. That's how I remember it goes on bottom. Now, maybe you like that LN button a little bit better. Look, that's an equal sign. Or we can do this as using the natural log, and you just do ln of A divided by ln of B. Again, positionally, A is above B, and we could just enter that into our calculator. And so what happens is it turns out to be really nice for us because now it gives us a way to enter all logs into our calculator. So it says evaluate using the change of base formula. I can't evaluate these in the calculator without that. Now, with log base 4 of 64, here's how I'm going to set it up. I would either say log of 64 divided by log of 4 and enter that in my calculator, and that gives me a value of 3. Or I could use ln of 64 over ln of 4, and that would also give me 3. Now, that is not saying log 64 equals log 64. It's saying the division of these does give you the same value. So it doesn't matter which one you're going to use. Now, if I had done that Snell method and worked it around and said 4 raised to what power gives me 64, we can see 3. Logically, that makes sense. But look over here at log base 8 of 25. If I were to Snell that around and say, 8 raised to some power is 25, 8 being raised to any power is not going to give me 25. It's not an integer. It's not something I could just go, oh yeah, that's 8 cubed or something like that. So that's where this is going to come in handy. If I'm using my on-screen calculator, I could say, well, I could do log of 25 divided by log of 8. And that gives me about 1.548. Or I could say ln of 25 divided by ln of 8. And that also gives me 1.548. Let me show you what that looks like. I just kind of gave you your answers, but let me show you on the calculator. So I can go ahead and set up my division problem here. I'm going to use my function button. So I would say log of 25, close parentheses, and then on bottom, I would say log of 8. So it gives me that 1.548. Now again, I am not saying that log of 25 is the same thing as ln of 25. You can see those are two different numbers. I'm just saying that the division of them, so set up my division problem, we're going to do ln this time. Ln of 25 is the same thing as ln of 8. And you can see those two values are the same. So the division gives you the same value. I'm not saying log 25 equals ln 25. I'm saying the division of them. But again, now we're able to plug in a whole lot more into our calculator, which I know you're going to love. So not only can we do base 10 and base E, but we can also do these other bases by using this change of base. So let's look at this next property we're going to do. It's called the exponent property. Now this property is going to help us again to change it up. And this property, if you move forward into additional math courses, is going to be really nice in other situations. Because what this exponent property does is it gives us a way to manipulate the problem and get something equivalent, but help us to solve. The exponent property says that we can take this exponent and bring it out here, and it becomes a large multiplier. So you can see in my result, I don't even have an exponent left over. The same is true with your natural log. It becomes a multiplier out front, and so that could really help our situation. So first, I want to work on that foundational skill, and then in problems to come, we'll look at how that can really benefit us. So let's just look at simplifying using this exponent property. So I could take this exponent, bring it out front, and that changes my problem to 2 log base 3 of x. Again, I'm just practicing this process. This one, I could take this exponent and bring it out front to give me 3 ln 7. This next one, if I bring this 1/3 out front, that gives me 1/3 log base 5 of 25. But I've worked with 25 enough that I could say that's 5 squared. So I got another exponent, so I could bring it out front, just become a multiplier. So 2 times 1/3 log base 5 of 5. And then don't forget that property that when the base and what you're logging is the same, that's just equal to 1. So really I've turned this into 2 times 1/3 times 1, which gives me 2/3. So that really went somewhere we didn't think that was going to go there, but you can see that exponent property at play and then that inverse property from earlier. And this next one, I'm going to rewrite it. When I bring this up to the top, that gives me ln of x to the negative 2. So using this exponent property, I could bring that out front. That gives me negative 2 ln x. Again, just rewriting that. Again, we're going to do a rewrite. We can rewrite radicals as an exponent. So this would be 5 to the 1/3. Similar to the one above it, I could bring that 1/3 out front. That gives me log base 5 of 5. And again, that's that inverse. That equals 1. So it's going to be 1/3 times 1. So I get a 1/3 for a total. Last one on this page here, I have log base b of b to the 3rd. Now remember, this is a square root. So when I make a root into an exponent, that would be log base b of 3 is the power, 2 is the root. So that's how I get that 3/2. Then on the exponent property, I could bring that out front. That gives me 3/2 log base b of b. And then we know that when that base of that log, when I'm logging, that cancels to give me a 1. Or it goes into 1 like we saw in those other problems. So I'm just left with 3/2. So this exponent property is going to be really nice, but it's not where we're going to stop. We can also do a product and sum property of logs. What it says is that if I have log base b of a plus log base b of c, I could rewrite it as log base b of a times c. And this is known as, when I go this direction, as expanding. Excuse me, wrong arrow. When I'm going this direction, expanding it out. When I'm going this direction, it's known as condensing. You can see it's simplified down into 1 log. Now, how does this all work out? Everything we're doing is based off our exponents here. So let's just recall some properties of exponents. If I had x to the 5th times x squared, then by properties of exponents, that would be 5 plus 2. Well, let's just play into that. If I had x to the 5th divided by x squared, properties of exponents is x to the 5 minus 2. You subtract them. So that's where your quotient difference properties of logs comes into play. Subtraction turns into division. And so again, this would be known as condensing it up. And if we went this direction, we would be expanding it out. So we want to be able to go in both directions. And so what I want to do is I want to look at expanding some items here. So it would say, rewrite as a sum or difference of logs. And so I'm going to take this and I'm going to slowly go through it. First, I'm going to expand this out. I'm going to get rid of division right here. Well, division from just a minute ago, again, these might be some properties you want to throw on a Post-it note to assist you as you go. Division becomes subtraction. So that would be log base 8 of x to the 4th y minus log base 8 of z to the 5th. We also saw that multiplication split into addition. So I could split that apart into log base 8 of x to the 4th plus log base 8 of y minus log base 8 of z to the 5th. Lastly, I can use my exponent property that we saw earlier and bring both these exponents out front, just in front of their individual terms, to give me 4 log base 8 of x plus log base 8 of y minus 5 log base 8 of z. And so this would be expanding this out. You can see once I expanded this out, I had log base 8 written multiple times. It started out with only written once. Now I do need to put parentheses around what I'm logging, especially when I go to enter it into the on-screen answers. But if it marks it wrong, you feel confident in it, just reach out. We can check that. Let's look at this next one. It says rewrite as a sum or difference of logs, meaning I'm going to get rid of all the products and quotients or exponents. So maybe let's make that note here. At the end of this, you're going to have no products or quotients or exponents. That's our goal. So I'm going to first break apart this division. That gives me ln of the square root of 3x minus 5 minus ln of 7. Then I'm going to rewrite this radical. That's 3x minus 5 raised to the 1/2. And then I'm going to pull my exponent out front. So it gives me 1/2 ln of 3x minus 5 minus ln of 7. And that would be my final answer. I'm not solving for x in these. I'm just practicing my properties. Let's look at this next one. Rewrite as a sum or difference of logs. So first I'm going to get rid of, well, let's see if we can simplify this up before we start breaking it apart. If I were to factor that top, it has a GCF of 5x. That would leave me with an x plus 7. And the bottom, I could factor out a 3, leaving me with an x plus 7. So before I ever start expanding that out, I'm able to kind of cancel out and simplify this up. So that would give me log of 5x over 3. Now, let's get rid of that division. So that would be log of 5x minus log of 3. And then I could separate out this multiplication. So that would be log 5 plus log x minus log 3. And again, when you go to enter this, you want to keep these parentheses on what you're logging. And you also see, as you enter log into the on-screen, it'll give you a parentheses. So these we've expanded out and had log written multiple times. Let's do the reverse and let's condense. So it says write as a single log. So I'm going to kind of do it in reverse. So addition is going to become multiplication. So I have log base 3 of 5 times a. And then subtraction became my division. So I'm going to divide by 5. Notice I now have log written only once. That would simplify by those 5's canceling. So that would give me log base 3 of a. Let's go to the next one. Now in our expanding, we always brought the exponent out front. In the condensing, I'm going to take and I'm going to bring those exponents up to get started. So that would give me log of x to the 1/2 plus log of x plus 1 cubed. And then addition is my multiplication, so I'm going to say log of x to the 1/2 times x plus 1 cubed. So that would be my final answer. Now I could change that into a square root, and I could say square root of x times x plus 1 cubed. Either one of those, but I definitely don't want to overwork it. Next one says write as a single log. So first thing I'm going to do is bring up any coefficients that are out front as exponents. That gives me log base 2 of 2 equal log, got a little carried away with my equal sign there, plus log base 2 of z to the 4th. Addition becomes multiplication, so I get log of 2 times z to the 4th. And so that would be my final answer. Or maybe you saw this. You looked at this initial problem and you said, wait, that's log base 2 of 2. That's just that inverse property. That's equal to 1. That also would be an answer. And we could say 1 plus, take that exponent, bring it back up, log base 2 of z to the 4th. If it said to rewrite as a single log, my answer again has a single log. So just kind of another way of looking at it. So pretty neat on how that's going to work. 2 more examples. Evaluate without a calculator by rewriting as a single log. So I'm going to pull that exponent up. That gives me log of 5 squared plus log of 4. Addition becomes multiplication, so that gives me log of 5 squared times 4. So let's see, that gives me 25 times 4, or log of 100. Remember, this is base 10, and 100 could be written as 10 squared. This would cancel, and it gives me 2. So kind of neat how all those pieces are working together, and I got that value out to give me 2. Last one, let's just kind of put our skills together. Solve the following equation. First thing I want to do is I want to condense this down so I only have 1 log on that left side. Addition here becomes multiplication, so it gives me ln of x plus 2 times x plus 1 equal to ln of 4x plus 14. Then by that 1-to-1 property, because I'm natural logging both sides, I can just set what I'm natural logging equal to each other. And so I'll have x plus 2 times x plus 1 equal to 4x plus 14. So I could square that out. That gives me x squared plus 3x plus 2 equal to 4x plus 14. And then now I'm just back to solving a quadratic. So subtract that 4x, subtract 14. That gives me x squared minus x minus 12 equal to 0. Everyone's favorite pastime. This will factor out to -4 and +3. And I get x to be 4 and -3. Now the problem with this is you do want to go back and check your answer, because all of this was just solving, this part was just solving for a quadratic. But in our initial situation, these two values are representing what happens up here in your ln. And actually, this is not going to be an answer, this -3. Because if I come up here and I plug in ln of -3 plus 2 plus ln of -3 plus 1, this gives me a -1. This gives me a -2. And I can't ln a negative value because of the restrictions on the domain. So just be careful if your result gives you multiple answers. Go back and see if it's applicable to the problem that you were starting with. Again, these properties are going to be really great. Maybe grab those on a Post-it note. Go through, practice those homework questions. Reach out if you need assistance.